So here we're going to look at solving some basic two-step linear equations. So our two-step linear equations are going to have a number, or we call it a coefficient, attached to the variable, like 2x, or 7x, or 1/2 x. Right? And they're also going to have an addition or a subtraction after the x. And when we're solving these two-step linear equations, it's really important that we do the steps in the correct order. Right? If we try to divide everything by 2 first, we're going to have a major issue. Like we divided by the number in front of the x in some of the other problems we encountered this year. And so the -5 is the thing that we say is least attached to that variable. Right? It's still on the same side of the equal sign as the variable, but it's not attached to it. Right? The 2 is attached to that x, whereas the -5 is not. So our first step is always to use either addition or subtraction to get rid of the stuff that's not attached to the variable, but still on the same side of the equal sign. So to get rid of a -5, the opposite operation would be to add 5. And as we've talked about in previous problems, when you add 5 to one side, you have to also add 5 to the other side of the equation, right? Because this is an equation. We're saying this thing is equal to this thing. If I don't add 5 on both sides, then I've no longer got an equation. Right? So 2x minus 5 plus 5, the -5 and the +5 should just cancel each other out. And on the left-hand side, we'll just be left with 2x. And on the right-hand side, 7 plus 5 is just 12. Now this looks like an equation that we've dealt with is just now a one-step equation. Right? We're going to use, in this case, division, but sometimes it'll be multiplication, to get rid of the things that are attached to the variable. We call this the coefficient, right? The 2 is the coefficient on the x. So we'll just divide by that coefficient, or divide by 2. When we do that, the 2's cancel, and we're left with x equals 12 divided by 2 is just 6. And remember that, right? A fraction, right? 12 over 2 is just a division. 12 divided by 2 is 6. And of course, we can always go back to our original equation and test it out. 2 times 6 minus 5 equals 7. Well, 2 times 6 is 12. So if I do 12 minus 5, I get 7. It checks out. So we're just going to practice a few of these, and hopefully they'll become really easy by the end here. So here we've got 3x plus 6 equals 21. So the first thing we want to say is, what's not attached to the x, but still on the same side of the equal sign? Well, that would be the +6. So if I subtract 6 from both sides, right, I should only be left with 3x on the left. And on the right-hand side, 21 minus 6 is just 15. And now we only have one step. We have something attached to the x, so get rid of it. The opposite operation of 3 times x would be to divide by 3. So we'll divide both sides by 3, giving us just an x equals 15 divided by 3. And 15 divided by 3 is 5. So our answer is 5. And for every single one of these, you can go back and you can plug it in to check and see if what you did is correct. And we'll do it one more time. We won't check all of them, but we'll check this one. We plug in the 5 as x, so 3 times 5 plus 6 equals 21. And 3 times 5 is 15. And since 15 plus 6 is 21, this all checks out. And we're certain that we've got the right answer. So if you were taking a test where you had to solve one of these, you could always go back and do the arithmetic and check and see if your answer worked. So here, 4x minus 10 equals -6. What's not attached to the 4x is the -10, so we'll get rid of that first by adding 10. On the left-hand side, we'll just have 4x now. And on the right-hand side, it might be a little tough if you're not super great with negative numbers. But if you start at -6, and you're going to the right because you're adding 10, it'll take you 6 units till you get to 0. And if we're adding 10, and we've only added 6 to get to 0, we're going to have to add another 4 to get ourselves over there, all the way with the +10. So 4x is equal to 4. Now we'll do the opposite operation of the multiplication between the 4 and the x, which is division. We know that anything divided by itself, 4 divided by 4, anything divided by itself is just 1. There's a special exception to that where if you're doing 0 divided by 0, that's not 1, but we won't worry about that today. We'll just go with 4 divided by 4 is 1, so x is 1. And we won't check this one, but again, you can go plug the 1 back in for x and see if it works out. And it will. All right. For negative 3x plus 12 equals 27, our first step is to determine what's not attached to the variable or what's not attached to x. That's the 12. So we'll do the opposite operation of plus, which will be minus 12. And that gives us negative 3x equals 27 minus 12 is just 15. And now the thing that's attached to the x needs to be eliminated. So we'll divide by negative 3. And here's where I see a lot of students start to make mistakes. They do the 15 divided by 3 just fine, say 15 over 3 is 5, and call it good. But remember that it's a positive being divided by a negative, which means that our final result should be a negative number. Right? So x is equal to negative 5. So this one looks a little bit different, but it's still in a similar form. Right? We have x divided by 3 plus 1 equals 7. The thing that's least attached to the x is the plus 1, right? The thing that is on the same side of the equal sign as that variable, but is least attached is the plus 1. So we'll get rid of that first by just subtracting 1. If I subtract 1 from 1, those will just cancel out. And we'll be left with x over 3 is equal to 7 minus 1. Well, 7 minus 1 is 6. And now we can get rid of that 3, but we're not going to divide by 3 because the operation that's happening there is already division. So when we did our one-step equations, we saw that when we divided by 3, we needed to do the opposite, which was to multiply by 3. So we'll multiply both sides of this by 3. Because 3 divided by 3 is just 1, the left-hand side is x, and the right-hand side, 6 times 3, is 18. So 18 is the only value of x that will solve that equation. Or negative 1/4 x minus 3 equals 2. The thing that is least attached to the variable is the minus 3. So we'll just add 3 to both sides, leaving us with negative 1/4 x equals 2 plus 3, which is 5. And now we saw these again in the one-step equations. Negative 1/4 x just means you're dividing that x by negative 4. So we can do the opposite of a division by negative 4 by multiplying this by negative 4. And if we do it to one side, we have to do it to the other side. So kind of breaking this down, a negative times a negative, another negative should become a positive. And a 4 times a 1/4, or 4 divided by 4 is just 1. So the only thing that we end up with left is just the x. And on the right-hand side, 5 times negative 4 is negative 20. 5 times 4 is 20, and a positive times a negative is always a negative. We'll just do 2 more here. Negative 2x minus 5 equals 10. So the first step here is going to just be to get rid of what is least attached, which is the minus 5. The opposite of minus 5 is plus 5. That'll leave us with negative 2x equals 15. And now when we divide by that coefficient, when we divide by that negative 2, we've got a little bit of a problem, right? In that 15 divided by 2 is not a whole number, right? Because 15 is not even, and So if we divide it by 2, we're not going to get a whole number. But that's okay. Most math teachers, and for my class, I would be totally fine with you giving me the answer of negative 15 halves. Okay? And that negative sign, even though it was down here with the 2, it doesn't really matter. You can put the negative in front of the fraction like I did. You could have put the negative up with the 15, right? You could have made it look like negative 15 over 2, or 15 over negative 2 like we had here. They're all the same thing because a positive times a negative is a negative, right? And so they're all just fine. Now, it's possible that your teacher might want you to put that into a decimal or a mixed number. And if they wanted it as a decimal, well, 15 divided by 2 is 7.5. So that'd be negative 7.5 or negative 7 and 1/2 if your teacher prefers a mixed number. I'm always fine with this answer right here. And as you get to higher math classes, normally they like the numbers to be written as improper fractions. All right, here's the last one we'll do. The thing that is least attached to the variable, but still on the same side of the equal sign, is the -4. So we'll add 4 to both sides to get rid of that, giving us negative x over 3 is equal to negative 7 plus 4. Well, negative 7 plus 4 is just negative 3, right? If you owe me $7 and you give me 4, now you only owe me 3. Okay? And so then our last step here is just to do the opposite operation. The operation here in the problem is division by 3, so we're going to multiply by 3. But if we multiply by just 3, we have a positive times a negative. And a positive times a negative will give us a negative x, so we don't want that. So instead of multiplying by positive 3, we'll multiply by negative 3. Then we have a negative times a negative, which should equal a positive. So we'll always, if there's a sign there of a negative, we'll always multiply and divide by a negative also. So this is going to get multiplied by negative 3 as well. And over here, the negatives cancel, the 3's cancel, and we're left with x equals negative 3 times negative 3. Well, a negative times a negative is always a positive, and 3 times 3 is 9. So our final answer is x equals 9. And that's the process for solving your two-step linear equations. First, get rid of what's least attached to the variable, but still on the same side of the equal sign. And then second, get rid of what's attached to it. And the first step will be done with addition or subtraction, and the second step will be done with multiplication or division.